Hello everyone, today let's solve the problem number 3, longest substring without repeating character. So what the question states here, we have to find the length of the longest substring without repeating the characters in the given string S. Right, so we have been given a string S here, we have to find the length of the longest substring without repeating the characters. So this is very important. So without repeating the characters means without duplicate characters means without repeating characters, they have clearly mentioned here. Find the length of the longest substring without repeating characters in a given string, nothing but without duplicate characters, right? So here you can clearly see, let's come to the first example here. So here we have ABC, ABC, AB, right? So ABC we have already A, B and C, right? So again you cannot consider A, B or C. So we have B here. So this one, if we take off this one, actually we can consider this one, ABC, right? So the length of the ABC we have to return in this case 3, right? The answer is ABC without the, with the length of 3. So we have to return the length they have asked. So output will be 3 in this case. This is fine. So let's move on to the second example here. So let's move on with the second example here. We have B, which is repeated 5 times here in this case, right? So we have to consider only once, B exactly once here in this case. So output, the length will be 1 at 6. The answer is B with the length of 1, right? So let's move on with the third example here. Let's see here. You can clearly see here the answer is, so here we have PW, W, KEW, right? So one thing is we have PW here, right? One thing is we have PW here. So the second thing here is this is of the length 2 basically. This is of the length 2, or we can just consider here WKE, right? So we can just consider here WKE here. So again we cannot consider W because it will be, W is a duplicate. We have already considered W here in this case. This is of length 3. So the longest, this one, longest substring without repeating characters here will be 3, which is of the length 3. Nothing but the substring here is WKE. The longest substring here is WKE, which is of the length 3 here in this case, right? So that's what we have written 3 in this case as well. So answer is WKE. So just give me a second here. In the explanation they have given, the answer is WKE with a length of 3. Notice that the answer must be substring PWKE. Answer must be a substring here. PWKE is a subsequence and not a substring, right? So this is nothing but subsequence. PWKE is a subsequence and it is not a substring. We have to consider the substring they have given, right? So we have to consider WKE, right? In this case. So WKE is, the answer is WKE in this case with the length of 3. So we have to return the length as output, right? So here in this case it is 3. So they've correctly mentioned here, right? I hope the question is completely clear. They have given wonderful examples as well, just to make us understand, right? So I hope the question is completely clear. What we need to do is completely clear as well. First, what we'll do, let's discuss the approach, then followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So let's discuss the approach step by step. The first thing here is we will be going with the sliding window approach. Just keep this in mind. We'll be going with a sliding window approach or 2 pointers, right? So just keep this in mind. So I have considered the same example, the first example that they have given in the question, right? ABC, ABC, BB. So we shouldn't consider the duplicates, but we have to consider the longest substring, not the subsequence. Longest substring and its length. We need to return the length as output, right? Here in this case, ABC. We already discussed this one, which is of the length 3 here, right? A is already present, B is already present, C is also present, and B is already present here, right? So ABC here in this case, ABC, the longest substring here is ABC, which is of the length 3 here. We know this one. Let's discuss this one step by step execution here, right? So the first step, what we'll do here, we will initialize max equals 0. We have to find out the maximum longest substring, right? So for that reason, first what we will do, we will initialize the max 0 and L equals 0 as well. L equals 0, we are going with the 2 pointers. Initially, let's initialize the L equals 0, starting of the string, starting index, sorry. And we will go with map of 128 equals 0. This one initially. Why we we are using this one, map of 128 within the array, this one. I have given 0 here, right? Why we are making use of it here? Because we have to store the last seen positions, right? So we have to store the last seen position somewhere. So that is the reason we'll be making use of map of 128 equals 0 here in this case. This is fine. So let's go with the second step here. We will iterate r from 0. So we will iterate r from 0. So we'll be going with L and R. 2 pointers of the sliding window here. Initially max will be 0 as well. So we will iterate r from 0 to s dot length minus 1 from the starting index to last index. I can just write here starting index to end index. Si is nothing but starting index, ei is nothing but end index, right? So we are iterating r. We will be moving the right pointer from the 0th index to the last index, right? So that's what we'll be doing here in the simple terms. I hope this is clear, right? Simple. If s of r was seen before, if string of this one, s of r, so the value means the character, if it was seen before, then we will update the L of max. Then we will update L equals max of L comma map of s of r here, right? This one we will be doing. Just keep this in mind. It will be very helpful while we write the code. It will be easier to write the code. Just keep this in mind. So next what we'll do, we'll update max of max comma r minus 1, r minus L plus 1, r minus L plus 1 in this case. So this is fine. This we'll see while write the code. You'll understand this one correctly. The final step here is within the step 2. The final thing here is we will store map of s of r here, string of r, right pointer, this one, r plus 1. This is equal to r plus 1. We are assigning this one to r plus 1. This is fine. Yeah, the final answer here in this case, after doing these steps, we will get max equals 3, which is of string this one, abc. If we go step by step, this one, here in this case, max we will get as abc, and here we will be considering this string for the first example I am speaking of. So the length of this one will be 3, abc. We will count this one, right? 1, 2, 3 basically, right? We will be counting this one, r plus 1. Why we'll go with r plus 1? This is 0 based index, starts from 0, 1, 2. So after this one we are going with plus 1 for the same purpose. Actually we have to go with the length, right? So it will be 3, right? So max here is 3 in this case, substring abc. That's what for the first example. So this is the approach that we will be going with. Simple to understand, right? While we write the code, it will be easier to understand. So now we are familiar with the approach, right? Let's discuss the edge cases one by one. So the first edge case here is, sorry, just give me a second here. So the first edge case here is empty string, right? We have considered empty string here. The output is 0. Why the output is 0 here? Because no characters present here, right? So the longest substring is 0 itself here in this case. So output will be 0. So let's move on with the second edge case here, single character. When I say single character, we have only one character in the string, yes, right here. So here we have only one character, so the length is quite obviously 1 here in this case, output. We know this one. So let's move on with the third edge case here. We are done with first and second edge case. Let's move on with the third edge case, nothing but all unique here. When I say all unique, we have all the unique characters here. We are considering all the unique characters here, right? So this, you can clearly see A, B, C, D, E, F. So the length is quite obviously 6 here. So here, every character is unique. So entire string is valid here. So the length will be quite obviously 6 here, right? So let's move on with the fourth edge case here, all same. So we have the characters where all the characters are same within the string is here, right? So we will be so the output here is 1. Why? Because only one unique character is present here in this case, nothing but A. Once we'll be considering here. So the longest substring is of length 1. We know this one, right? So I hope this is clear, simple to understand. Let's move on with the fifth edge case here, repeating with gap. So when I say repeating with gap here, we have A, B, C, B, E, F, G. A, B, C, B is repeated, E, F, G means repeating with gap. So B is repeated here, right? Repeating with gap, right? So here the longest substring is C, B, E, F, G. We can consider this one instead of this one. A, B here. Let's not consider this one. We can just consider here C, B, E, F, G. Right? C, B, E, F, G, which is of the length 5 basically. Sorry, not the 6 here. This is of the length 5. C, B, E, F, G. Right? Which is of the length 5 in this case. Right? So I hope this is completely clear. Right? These are the edge cases that we need to consider. The first one is for empty string. The second one is for single character. The third one is for all unique. The fourth one is for all sign. And the fifth one is for repeating with cap. Right? So I hope all the edge cases are clear. Now we are familiar with the approach as well as we are familiar with the edge cases. So as we are familiar with the approach and edge cases, it will be easier to write the code. Now let's start writing the code. Here, first step, what we'll do here, let's initialize the max length and left pointer here. We have discussed this one in the approach. I'll just give here max. Initially, let's initialize the max to 0 as well as left pointer to 0. Right? 0th index. This is fine. So, we will be making use of the ASCII array. ASCII array. So, if you remember, map of 128, if you remember, we initialized that one to the 0. Right? So, we will be making use of the ASCII array to store the last seen index of character. Last seen index means last time where it was seen. We have to store it somewhere, right? So we will be making use of ASCII array to store last seen index of the character. So we can write this one in this way. Means we can articulate that one in the form of code in this way. I'll just make use of the variable map here. This one, let me write new int of 1 to 8. This is fine. This is completely fine, right? So the next case here is we have to iterate over each character, right? Or we have to iterate over the characters, or we have to iterate over each character. So I'll just make use of the simple for loop here. I'll just keep r equals 0, r less than length of the s, and let me increment the s. This is fine. Oh, sorry. Let me increment the r here, not s. This is fine. So within this for loop, we have already discussed these things. We know that we have to move the left pointer if the character is seen. Here, mat.max of L comma map of this one s dot char at this one r. What we are doing here, we are just moving the left pointer if the character is seen. This is fine. So the next step here is we have to calculate the max length, right? After moving the left pointer, if the character is seen, the next step here is obviously we have to calculate the max length. I'll just give here mat.max of this one. Here within this, I'll just give max here and r minus L plus 1. Plus 1 as it is 0 based index, right? We are going with the 0 based indexing. So I'll just give a plus 1. We have to calculate the max length. We have to go with the length. Length starts from 1, right? So we'll go with, we are calculating the max length here. So I hope this is clear, easy to understand, right? So the next step here is we have to store the character, nothing but index plus 1. Again, we have to store the character index plus 1. So this one will be map of s dot char at this one r. This is fine. This is equal to r plus 1. Means we are storing the character here, mainly index plus 1, right? R plus 1 in our case. So finally, I hope till line number 9 it is completely clear. The next step, the final step, we know we have to return the maximum length. So basically I'll just give here return max. So I hope this is clear. So let me format the code once and let me hit the run button. This is it for the code. So here we have error saying what we have here, cannot find the symbol. What I have done here. So this one Java, right? Fine. This is fine. So let me hit the run button. So I get confused with JavaScript. So this is fine. So now you can clearly see the sample test cases are getting passed. Means the code works absolutely correct in this case. Let's see. I'll just hit the submit button. Let's see whether this works for all the test cases or not. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is sliding window with hash map. We know that we have went with sliding window with the hash map. So why we are making use of the hash map here? Basically, sliding window we have already discussed that we know that we are making use of the 2 pointers or sliding window. So we are making use of the hash map because we need ASCII array again. So we have discussed this one multiple times. Again, I'm telling this is important part basically, right? So we need ASCII array to store the last seen index of each character. This is the main part of the program actually, right? So we are making use of the ASCII array to store the last seen index of each character, index of the character, right? So that is the reason we are making use of the hash map. So the approach that we went with here is this one, sliding window with hash map. So overall time complexity here is big O of n. So why here the time complexity is big O of n? Because each character is processed at most twice here. Each character is processed at most twice, because once if it gets repeated, then we are not considering that one. Then we shouldn't consider, right? So we have to process each character at most twice in this case, right? So each character is processed at most twice here, R and L moments, right? So overall time complexity would be obviously big of n here in this case. So the space complexity, what will be the overall space complexity here? We have made use of the ASCII array or the hash map, right? So this one I'm speaking of, map new int of 128, whatever we have given here. So map of 128 here, this one, new int of 128 or map of 128 we discussed in the approach, right? So this one is fixed in size. This is fixed in size, means we are making use of the constant space here, right? Line number 4, you can clearly see here. I'm speaking of map equals new int of 128 or map of 128 also we can consider, right? So this is fixed in size. So we are making use of the constant space. So overall space complexity would be big of 1 in this case. So the time complexity would be big of n, and the space complexity would be big of 1 for the code that we have written. I hope the complexities are clear. I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching.